In this video, we're going to talk about how to apply trapezoidal rule in real life situation. First, let's review about average value of a function. Recall that when you have f of x from interval a to b, the average value of f of x from a to b is 1 over b minus a times the integral from a to b of f of x dx. So we need this information in order to solve example 2 here. Example 2 says an observer measures the outside temperature every hour from noon until midnight, recording the temperatures in the following table. So we need to find what was the average temperature for the 12-hour period. Remember, in order to find the average value of f of x, you got to take the integral of f of x from a to b and then multiply by 1 over b minus a. So here we're finding the average temperature. So what we need to do is we got to find 1 over b minus a, and we got to take the integral of t of x dx from a to b. Now what is a and b? Well, look at the data here. The noon can be represented as when x equals 0. And that represents 1 p.m., 2 p.m., 3 p.m., and so forth. And the midnight can be represented as 12. So A in this case will be 0 and B will be 12. Now the question is, how are we going to get the integral of t of x from a to b? We have no function of t of x. What's given is table. So what we're going to do is we're going to estimate this integral using the trapezoidal rule. Now, how many trapezoids are in the interval from 0 to 12 by a given table? Well, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 trapezoids. So n equals 12. Since we know what a is, b is, and n is, we know that the height of the trapezoid will be 12 minus 0 over 12, which is going to be 1. Now think about it. What is the distance from 0 to 1? It's 1. What is the distance from 1 to 2? It's also 1. That is going to be the height of the trapezoid. Now recall that this is the formula for the trapezoidal rule, and you have to go all the way up to f of x12. Now we got to indicate what is x of 0, x of 1, and so forth. So x of 0 is going to be this value right here, 0. That is going to be x of 0. And 1 is going to be x of 1, x of 2, x of 3, and all the way up to x of 12. So in this case, x of 12 is 12, and x of 11 will be 11. So we know that the h is 1. So it's going to be 1 over 2 times the quantity. What is f of x of 0? Well, that is going to be 63. Plus, what is f of x of 1? That's going to be f of 1 is going to be 65. So it should be plus 2 times 65 plus 2 times, what is f of x2? That is going to be 66 and so forth. Okay, I'm not going to write all this process. You know what it means. And you got to find all the terms in the middle And what is f of x of 11? 58. So 2 times 58 plus f of x 12, which is f of 12, that's 55. Now remember, don't forget to find all these middle terms here. Now after the calculation, you'll notice that you get 782. Now that is not our final answer because this represents, 782 represents the integral from 0 to 12 of the temperature. Now what we got to do is, you can don't forget about 1 over b minus a. So what we need to do is, to find the average temperature, we need to do 1 over 12 minus 0, which is 12 times 782. And that's approximately 65.17. So the average temperature for the 12-hour period was 65.17 degrees. If you round it, that's about 65 degrees. Now be careful. A lot of times the students make mistake when they find average temperature by adding all the temperature, so 63 plus 65 plus 66 and all the way up to 55, and they divide by 13, which gives you 64.69230. But when we did the integral, the answer came out to be 65.17. The mistake of doing this way is that you're not really accounting for what's happening between 0 and 1, 1 to 2, 2 to 3, and so forth. So be careful not to make this mistake.